Hello, sir. Good evening.
Check. Yes.
Hello.
Okay. Yes. Good evening. Good evening. Just a second. Yes. Now it has unlocked. Yes. Okay. So it is getting recorded automatically. Yes. So today we will start with something after regression. Sorry. Yeah. So the volume is also maximum. Sorry. Yes. So today we will start with regression. Regression we have just discussed in the last session. Today we will start with some basic probability concepts. Okay. So I could remember to bring my pen tab. So you can share the screen, and here I'll be able to write few things. Yeah. So probability is basically, to begin with, it is based on past data. It is primarily based on past data. Yeah. So suppose we have an example. We see in the last 3 months, we have seen whether it rains on Monday or not. Rains on Monday. Yeah. So the previous Monday we saw it rain. The Monday before that we saw it didn't rain. So things like that, past data we can collect. Suppose in the last 3 months it has rained 5 times on Mondays. On other Mondays it has not rained. Yeah. Similarly, Tuesday, Wednesday, and so on. So 8. So based on past data, we can say the frequency of raining on a Monday is 5, and what will be the relative frequency? Yeah. So that is how many times it could have rained, and out of that, how many times it has rained. So how many Mondays are there basically in 3 months? Yes, 12 to 13. Say, let us take 12. Yeah. So the probability of raining on a Monday will be 5 out of 12. That is the relative frequency with respect to total number of possibilities. Yeah. At the most, it could have rained 12 times. Out of that, 5 times it has rained. So the relative frequency based on past data. Again, this is not some universal truth. It's not that probability of raining on Monday all over the world for all the time will be 5 by 12. Just based on the previous data we have, the probability of raining on a Monday is 5 by 12. Okay. Similarly, the probability of raining on a Tuesday will be, say, 10 by 12, and so on. Yeah. Sometimes, most of the times, we go by past data, and the frequency gives rise to probability in this way. Yeah. Sometimes we also use logic. Yeah. When there is a clear-cut logic, there is no reason to doubt. Then by that logic also we try to find out probability. For example, simple cases like tossing of a coin. Yeah. So tossing of a coin, if we actually toss 10,000 times, we are likely to get half heads and half tails. So there is no reason that a unbiased coin, a fair coin, will prefer heads or tails. Yeah. The outcome of uh, an unbiased coin will not be inclined towards one outcome. Yeah, heads or tails. So half the times we can think logically say that half the times it will give us heads, half the times it will give us tails. Yeah. So by that kind of clear logic also, many times we declare the initial probability at least. Yeah. So the probability of getting a heads will be given nothing else. It's a fair coin. The probability of getting heads is 0.5. Yeah. Similarly, die, rolling of a die. You might have played Ludo in your childhood with your friends during summer holidays. Now it is also summer. Now the season is also summer. So yeah. So the rolling of a die. What are the outcomes there? It could be 1, 2, 3, 4, 5, 6. I hope you know what I am talking about. That there is
Yeah.
this die like this. One side is 1 dot, the other side is 2 dot, the third side is 3 dot like this. Yeah, and so on. Yeah. So the probability of getting a 1 will be how much? Logically, again we are seeing, again we are using logic. Yeah. We are
1 by 6. 1 by
yes, 1 by 6. Yeah. Again, we are not rolling the die say 10,000 times or 1 lakh times. If there was no other way, we would have had to do that, and somebody would have done that. There are mathematically inclined and statistically inclined people who will be very happy to do such experiments. Yeah, and maybe some industry which sees value in that will be able to support them also. Yeah. So if there is a clear logic, we go by that logic to find probability, or primarily we go by past data. So this is the basic of probability. Now the question comes, what about situations when we have to find out probability of two things together? Yeah. Say probability of Shriram SHRIRM. Yes. Probability of Shriram being in a session is say 6 by 10, and probability of Bhaskar being in a session is say 5 by 10 or 7 by 10. Let us take 5 by 10. Yeah. So now there are two situations where we can try to find out what is the probability of Shriram and Bhaskar both being present. That is, and Shriram and Bhaskar. So what will be the probability? What do you think? Whether it will be higher or less than these two values? Whether it will be lower than 5 by 10 or
I think
higher?
it's the less one. I mean, 5 by 10.
5 by 10. Okay. See,
we have to multiply or no, we have to plus it, right?
Hello,
When it is and, we have to plus.
sir. Am I audible?
yes, both of you are. Yes.
Okay.
Yes, you're right direction. Yeah. So this is one event. its probability is of course less than 1, and this is another event, its probability is also less than 1. So something which happens less than 100% of times, both events are like that. So the probability of both happening together will be less. Yeah, will be less than even 5 by 10, even the least value. Yeah. So
Okay.
in that case,
Yeah.
yes. So in that case, because if the other event was sure, yeah, 10 out of 10, then we would have said that probability of both the events happening together would have been 5 by 10. Yes. Other event is also not sure. Other events probability is also less than 1. So definitely the probability of both these events happening together will be less than even the lowest value. And in that case, we find the probability by multiplying the probability of two events. Yeah. This is probability of S and B. Now, what is the probability of Shriram or Bhaskar being in the present? If any of them is there, we will consider that as a success. So in probability, there is a success and failure terminology. Success is basically what we are trying to observe. Yeah.
Yeah.
If it doesn't happen, then that means failure. Okay. So in probability, the word failure is not anything wrong or demeaning in any sense. Probability just failure just means what we are trying to observe is not happening. Yeah. So in that sense, if Shriram is there, then also we will say that we have observed what we wanted to observe. If Bhaskar is there, we will say we have observed what we wanted to observe. If any of them is there, any of them are there, yeah, then we will say the event has occurred. The event what we wanted to observe has occurred. So this is a typical case of OR. So in this case, what will be the probability? Whether the probability will be greater or less than the highest probability or less than the least probability of the two.
Greater than the highest one.
Greater than the highest probability.
Yeah.
Yes. Yes. So
basically we are adding, I believe, right? Basically we
yes.
need to add. Okay.
Yes. So in this case, when any of the events, any of the outcomes give us success. So in this case, we will be adding the probability. Yes, initially this logic is correct, but suppose these two events can happen together. Yeah, they can also happen together. So this is say Bhaskar, this is say S. So there is one region, this region, which is common. Yeah. So when we add the probabilities, so what we find out is this total area. Yeah. This total area. Yes. So if we want to do that, what we find is we are adding this shaded area twice. Once with this B, once with S. Isn't
Yes.
it?
Yeah.
Yes. So to make up for that, what we do is we subtract from this sum, we subtract the common region once, because we have added the common region twice. We subtract the common region. This common region is actually this thing. probability of A and B. Yes. Yes. So minus probability of S and B. S and B. Okay. So what we will do? Actually, we will try to calculate in this case, if this is a situation like this, what we will do is 6 by 10 plus 5 by 10 minus this value. 5 by 10 into 6 by 10. Okay. Now going back and reflecting a little bit, in the process also you would have realized that this is 6 by 10, this is 6 by 10, and this is 5 by 10. If we simply add it and do nothing else, we will get 11 by 10. Yeah. So now 11 by 10 is greater than 1, which cannot happen. An event can be only 100% sure. You cannot be more than 100% sure. Though figuratively, some of our friends are in the habit of saying, so I'm 120% sure, but that is just a symbolic language. Yeah.
Right.
So maximum you can be 100% sure. So probability cannot be greater than 1. Yeah. So now the further thing which we have done also ensures that this probability will not be greater than 1. Okay. So this and or logic we have seen just now. Okay. Now after this in probability, what we do is we study something called as distributions. Yeah. Probability distributions. Earlier there was so many colors. Where are the other colors? Okay, I need to check. I think I need to update this. After around yeah, quite few months, 4-5 months I am using it. I think the setting is gone, but I'll check.
What is this? This is tab. Is application or how?
Yes,
What
there
you
is a pen tab like this. Oh, okay. I'm using a background, so it won't be visible. This is like a big mobile and with a
Okay.
special pen.
Okay.
So yes. So what is the need of having this probability distribution concept is when we see some data gets generated by a process. Yeah. The process can be something simple like tossing a coin. Yeah. Or say observing whether somebody is present or not. Yeah. Or how many cars pass through a toll naka. Yeah. So these are all processes. Okay. So there are certain processes which follow a set of rules. Once we know that a process follows certain rules, we can classify the process correctly. An unknown process, say, we can classify the unknown process correctly. And once we are able to do that, say, let us initially call distribution 1. Distribution 1, distribution 2, distribution anything, say alpha. Yeah. So once we know the process we are studying follows the rules required for it to be classified as distribution 2, the rest of the things become very easy. Yeah. Once we know which distribution it is, we can find out the probability very easily, probability of any event in that process. Yeah. Because statisticians have already done that. If this is the distribution, such and such way, we can find out the probability. Yeah. So statisticians have done that many times through experiments, many times through logic. Yeah, very clear logic. They have made our task very simple. Yeah. So one is that probabilities we can find out very easily. The other point is the basic statistics. What are the basic statistics of any data set? That is mean, yeah, standard deviation. These things can also be found out very easily. Again, because statisticians have found out simple ways to do that. But before all this, to be able to use all this, we should know which distribution the data is. Yeah, that we will know by understanding which rules, or we generally call them conditions. Which conditions the process generating the data which we are trying to study follows. Which conditions the process follows. Yeah, based on that, distribution can be found out, and based on that, probability and basic statistics can be found out. Now, coming to an example. Actually, numerical example we will have, but before that, also let us see a type of distribution. Yeah. Probability distributions. Yeah, this is already done. Yes. Now, there is something called as one kind of distribution called as binomial distribution. So when do we say that the data follows binomial distribution, or the data is binomially distributed? Okay. So when the process obeys certain conditions. So what are those conditions? In binomial distribution, there are 3 conditions which the process should follow. The first condition is each trial has only 2 possible outcomes. Yeah, either heads or tails, either absent or present. In fact, in probability, we will also realize, you would have also realized that the probability definition also matters. Yeah, like if there are 3 colors, if we study, if we try to observe colors of shirts, yeah, shirts or any women's t-shirts or anything. So it can say it is blue, green, or yellow, and we just want to observe when it is green. Yeah. So in 100 observations, when it is green. So we can define the event in such a way that it follows this condition, that there are only 2 outcomes. How is it possible? Blue, green, yellow, there are 3 possibilities. How can we convert them into just 2 outcomes? Any ideas?
Two colors we can group in one, and then suppose if these 2 are not there, then third one is present, something like that.
Yes, in that direction. So we can say it is either green or not green. When we are interested in only green, so we can say whether it is either green or not green. So it becomes two outcomes.
Two.
So, yes, so that way we can redefine also sometimes. Yeah. So this is the first condition, but that is not all. There are two more conditions. The second condition is probability of outcome remains fixed over time. What is meant by this? So once we do this experiment, in one observation, once we observe, say we toss a coin and observe once, the probability of outcome is logically fixed. Yeah, either logically or from previous data, huge amount of previous data, it is fixed. For example, the probability of getting a heads in one toss of a coin. Yeah, we might have tossed the coin millions of times, but in the next toss, the probability of getting a heads is 0.5. That is based on either clear logic or a huge amount of data. Yeah, that is what is meant by probability of outcome. The two outcomes, of course, there are only two outcomes. Yeah. So the probability of any of the outcomes, if one is fixed and there are only two outcomes, other automatically becomes fixed. So in that sense, the probability of outcome is fixed. Yeah. Even in the case of range data, which we saw. Yes. So whether it rains or doesn't rain, we can define such outcome in we can define the event in such a way that there are only two outcomes: rains or doesn't rain. Yeah. So in that case, the probability of raining will be based on previous data. In toss of a coin, we are based on logic. Here, in this case, the probability of raining on a Monday, we can say is fixed because we have huge amount of previous data, and that says the probability of raining on a Monday is 5 by 12. Yeah, based on our previous data for our case. So that is what is meant by the second condition. Yeah. And the third condition is trials are statistically independent. That means outcomes are statistically independent. What it means is, say again taking a tossing of a coin, whether in the previous attempt, in the previous toss of a coin, we got heads or tails, is not going to affect what we will get in this toss of a coin, in the present toss of a coin. And what we get in the present toss of a coin is not going to affect what we will get heads or tails in the next toss of a coin. So one outcome is not affecting the outcome of other trials. Yeah. So that is what is meant by statistically independent. These three conditions are clear.
Yes, sir.
Yes.
Yes,
Okay.
sir.
Yes. Okay. Very nice. So when any process follows these three conditions, we will say that the data generated is binomially distributed. Yeah. Or the data follows binomial distribution. Once we know that, we can find out probabilities in rather simple ways. Yeah. For example, say we want to find out the probability of, let us take a simple example. Probability distribution only we are discussing. There are so many colors. Okay. But black went away. Okay. At one time we can have only one color. Yes. So yes. So let us take a simple example. Say getting two heads in 5 tosses of a coin. Of course, a fair coin. Yeah. What is the probability of this? So what will be your guess? Probability of getting a head in the next toss of a coin we know is 0.5. But this case is little involved, little complicated than that. Yeah. So what it is asking, we are tossing 5 times and 2 out of 5 times, any 2 out of 5 times, we should get heads. What is the probability of that? So before that, and any complicated situation, however complicated the situation is, when probability concept is involved, we try to have, uh, we try to get to the first principles or get back to the first principles. The first principle is probability is basically number of favorable outcomes divided by total number of outcomes. So by this logic, how do we get probability of heads is 0.5? Favorable outcome, if we are observing heads, the favorable outcome is 1 and the total number of outcomes is 2 heads and tails. Yeah. So the probability of getting a heads is 1 by 2 like this. And in the rain example also, this 5 is the number of favorable events. 5 times. We are interested in observing when it rains. So 5 times it rains on a Monday. On 5 Mondays it rains. So 5 is the number of favorable outcomes. What is the total number of outcomes here? It could have rained 12 times. Could have rained 6 times, 7 times, 8 times, maximum of 12 out of 12 times. That is the total number of outcomes is 12. And number of favorable outcomes is 5. Yeah. Now coming back to our problem. Probability of 2 heads in 5 tosses of a coin. What it will be?
The favorable outcomes are 2 heads and total outcome are 2 by 5, but I'm not.
So total outcome is not 5 or 2 by
Yeah,
5.
right.
Yeah.
That's the confusion. heads in 5 tosses.
So let us try to visualize what is going on. See, these are 5 tosses.
Okay, 5 tosses at a time. Okay.
Yes, you can consider it at a time. Yeah,
Okay.
maybe if one person is tossing a coin, he will do one toss at a time. But for practical purposes, we can say that we are having 5 tosses uh, together. Yeah. So either these two can be heads, yeah, and these 3 are tails. So this is one such event, 2 heads in 5 tosses of a coin, or heads could be here. This could be 2 heads, other 3 could be tails. So there will be so many such possibilities. Yeah. So we will look at how many such combinations can be there a little later. First, what is the probability of this outcome? First heads, second heads, third tails, fourth tails, fifth tails. How can we find that out?
So this is 2 by 5.
No, it is not exactly 2 by 5. Uh, because 5 is not the total number of outcomes. Yeah. So here the situation is little different. If we want to compare it with the and or situation, yeah. Yeah. So this and or situation, if we come back to this, so in which situation it will fit better? There's 5 outcomes, 5 tosses are together in a way. So whether it will fit into the and situation or situation.
One
I think it fits into the and situation.
And situation, because these are all happening together. First, second, third, fourth, fifth, they are happening together. So it's a and situation, and in and situation, we get the probability by multiplying the
multiply. Yeah.
individual probabilities. So what are the individual probabilities here? Probability of getting a heads is 0.5. Probability of getting a heads again is 0.5. Probability of getting a tails coincidentally is also 0.5. Yeah, if probability of getting a heads is 0.5, probability of getting a tails is 1 minus probability of getting heads. There are only 2 outcomes. Probability of one outcome is 0.5. Probability of other outcome will definitely be 1 minus 0.5. Yeah, because the total probability is 0. The total probability can be only 1. Yeah. Again, probability of getting a tails here is 0.5. Probability of getting a tails here is 0.5. So now in for this particular instant, for this particular possibility, first toss gives head, second toss gives head, third, fourth and fifth toss gives tails. For this just one probability, one situation, our probability will be multiplication of all this. Yeah. So this is basically probability of heads. Yeah. Uh, Yes. And probability of tails, how many times it is? 3. Okay. So you can observe that the exponents will give us the total number of toss. So twice is heads and thrice it is tails. So 2 plus 3 should give us the total number of tosses, total number of trials. So this is one situation. Now, how many ways it can happen that there are 2 heads? How many ways you can arrange 2 heads in 5 positions? It can be first and second position. It can be first and third. It can be first and fourth. Yeah, it can be first and fifth. So like this, try to find out. We use the concept of combinations. Okay, selecting 2 out of 5. This is a case where we are selecting 2 out of 5. So how many ways that can be done? To find that out, we use the concept of combination, which we write like this, and it is defined like this: 5 factorial divided by 5 minus 2 factorial multiplied by 2 factorial. Yeah. So what does this factorial sign mean? Everybody knows what is meant by 10 factorial. Yeah. So it is very
5 into 4 into 3 into 2 into 1.
yes. Yes. So 5 factorial will be 5 into 4 into 3 into 2 into 1. Many times we do not write the 1 at the end, because multiplying by 1 will not change the result. Yeah. So similarly, 5 factorial, here in the denominator it is 5 minus 2, that is 3 factorial, and here it is 5 factorial again. So what it will be? 5 into 4 into 3 into 2 into 1. Denominator will be 3 factorial, that is 3 into 2 into 1, and 2 factorial will be 2 into 1. So this 3 factorial will cancel out these factors. 2 also will cancel out 4 to give us 2. So this becomes 10. So in 10 ways we can arrange 2 heads out of 5. Yeah. And the probability of one such situation is this much. This much. Probability of one such situation, which we have drawn in boxes. Yeah. In this diagram which we have drawn, the probability of one such situation is this. And how many such situations there can be? 10. Yes. So the probability of 2 heads in 5 tosses of a coin will ultimately be 10 into this 0.5 square multiplied by 0.5 cube. Okay. This logic is clear?
Yeah.
Yes. Okay.
Yes.
So, yes. Okay. So we can see it on the PPT also. This is how it is usually written. This NCX can also be written like this in such a long bracket, n at the top and x at the bottom. That means the same, ncx. Yeah. And then this is p to the power x. That means probability of success. In our previous example, it was success was heads, because that was what we were trying to observe. That is why it is called as success. So p to the power x, and q is the probability of failure. That is 1 minus probability of success in case of binomial distribution. Yeah. So q to the power n minus x. N is the total number of trials. In our previous example, it was 5. Yeah. So failure to the power total number of trials minus number of outcomes we are trying to observe. Yeah. So this is how a little expanded form of the formula looks like. Yeah. Now let us come back to the previous example of rains. Where is it? And or yeah, rain. Yeah. So given this situation, from the previous data, given this situation, probability of raining on a Monday is 5 by 12. What is the probability of raining on 3 Mondays out of, say, 6 Mondays? Any 3 Mondays out of 6 Mondays, the next 6 Mondays. You can take a moment. I think, yeah, one distribution in a session of 1 hour is good to absorb. Yeah, we can have more problems. Yeah, I have good problem sets, so I'll give you the problems for practice later. Once normal distribution is over, so we will study binomial distribution, which we are doing now, then Poisson's distribution and Normal distribution. Yeah. Normal distribution will be the most widely used distribution. Further, it will be required for hypothesis testing and various other places. Even Six Sigma methodology is basically based on normally distributed data. It is also the most commonly found distribution naturally. Yeah. Yes, so I think I got digressed a little bit. Yes, so this is the situation, raining on a Monday. From previous data, we have this probability 5 by 12. Now we want to find out what is the probability that in the next 3 Mondays, the next 3 out of 6 Mondays. Yeah. That is on 3 Mondays out of the next 6 Mondays, it will rain. What is the probability? Only 3 Mondays, right? It's not at least 3 Mondays. Only 3 Mondays. The other 3 Mondays, it should not rain. That is the same situation, same kind of situation we just discussed with tossing of a coin.
Here it is or condition, raining or not raining.
Yes, raining or not raining. So again, we can say, we can draw 6 boxes. Yes. So by the previous logic, what will be the probability?
This will be
So
3,
suppose
3, 6. 3, 3, 6. This is the combination.
this thrice it should rain and thrice it should not rain in the next 6 Mondays. So suppose we take one situation where the first Monday rains, the second Monday rains, and the third Monday it rains. Yes. And in the other 2 Mondays, there is no rain, no rain, no rain. What is the probability of this situation occurring? Again, it is a AND
So
situation.
it will be a multiplication between
3 by 6 and
3 by
3 by 6 and 3 by 6. Right? Or no? Right.
3 by 6. Why 3 by 6? From the previous day, probability of raining is 5 by 12, right?
Okay.
So it will be 5 by 12 multiplied by 5 by 12 multiplied by 5 by 12. And probability of not raining is how much? Probability of raining on a Monday is 5 by 12. Probability of not raining on a Monday is how much?
7 by 12.
Yes, that is 1 minus
1
5
minus
by
5 by.
Yeah.
yeah.
But sir, this 5 by 12, because we are considering different example, right? Next, it is from next 3 months we are
It is
talking about.
yeah, next 3 weeks. Yes.
Okay.
So 1 minus 5 by 12, we can write it as 7 by 12. So 7 by 12. So this is the probability of just this arrangement. So it can happen that first week it rains, second week it doesn't rain, then third week it rains, fourth week it doesn't rain, fifth week it rains. Then also we will have 3 times raining. Yeah, raining on 3 Mondays. Yeah, we want to find out probability of raining on 3 Mondays out of next 6 Mondays. So this is one arrangement. How many such arrangements can happen?
3, C, 6.
Yes, 3C6. Yeah. So 3C6 will give us 6 factorial. 6 minus 3 factorial. 3 factorial.
Divided by 30.
Yes. Yeah. So we can easily calculate. In business analytics exams, you will be given simple calculators, not scientific calculators. Yeah. So with a simple calculator, you can easily calculate this part. And also after simplification, little bit of simplification, you will be able to calculate this part also. Yeah, that's 3C6 part. So that will be our answer. What is the probability of raining on 3 Mondays out of 6? Okay. And this whole process, uh, the process behind this data, which is getting generated, is called binomial distribution. Yeah. Yes. So today we will have this much only. Yes. So this timing is all right, isn't it?
Yeah.
Yeah.
Yes.
Yes. So let us try to have at least Tuesday 9 to 10 every week. Yeah. Then if we get one more day, then we can skip Saturday. There are some subjects. No. Okay, your subjects are going on fine. Yeah. Yes.
So there is one subject which is not started yet.
Which one is that?
Operations, right?
Okay, kill cursors.
Yeah, there is no single lecture has been done until now.
Yeah, he has taught the other batch, the 13th batch last time also, in last semester, immediately previous semester as well. We hope this week he will be able to start. Yeah, he has confirmed. He has confirmed multiple times. That's why we are also not going for any other faculty. So, and he is a very dedicated teacher from last semester we observed. So let us see this weekend he should be starting. Yeah.
Yeah, but then if we have an exam on 16, 17, then it's only one day.
Yes. For exam, there will be subjects where you would have had only 2 sessions before the exam. Yeah, 2-3 sessions. Still, we will have one exam because it will give a structure to the semester. And by third week of May, we would like to have the end semester with all other courses because
Yeah,
yes. Otherwise, till the end, till your 4th semester, this course will be lagging. Executive MBA means exams happening after 1 month of other courses. So it will continue that. Yeah. So we will give a structure to the exams.
So May end is the target to end this semester.
Yes. May 19th. May 19th has been declared as start of end sem exams. Yeah.
Sir,
Okay.
I have one more question. I mean, maybe your help is required. Just I saw, today I received one email regarding documents, and I
Yeah.
found against my name also it's showing most of the documents pending. But in fact, actually, migration is the only one pending for me. So, do I need to call Sonal Bhosle ma'am or?
Yes. First, call her and check. Yeah.
Okay, because last time I did send an email, with all the documents which I submitted and uploaded to TCS IAN. So I was in an impression that from my side only migration is pending because it's from that university is still not received.
Yes.
So, yeah. Okay,
Yeah,
but I will call her. I will call her tomorrow and just check.
yes.
Okay.
Okay, then we will meet again.
Okay. Yeah.
Okay. Thank you. Thank you, sir.
Okay, good night.
Thank you.
Yeah. Yeah. Bye.